Hungers? Okay, so you asked for this. Well, first period asked for this, so the rest of you are suffering. So, here we go. Conjugate root theorem. We are continuing the notes from Friday. Technically, that's today. Okay, you're continue the notes from Friday. So we're moving on to conjugate root theorem. So if you remember, we talked about complex numbers, and we were talking about shoes. And I said that when you go buy a shoe, you don't want different color shoes, and you want them to be the same size, but you need a left shoe and you need a right shoe. So conjugate root theorem works that way, meaning if you have a complex number where it's a radical, or it could be a radical, but you have a complex number as a root, then the other shoe must also be a root. So down here it says, remember, pairs of shoes. Okay, so A means it needs to be the same. So same color, that means it should be the same. And then you'll have the left shoe, which will be negative, and you'll have the right shoe, which will be positive. Pause that right there. Cool. So ultimately, what I am saying is complex roots come in pairs, but so do radicals. Radicals work the same way because technically I is what? Yes. Square root of -1. Cool. So we have negative radical will also, the root will also be positive radical. Okay, so now we are in example 3. And this says, using the conjugate root theorem, yes, I shortened it because I'm lazy just like you guys, to identify roots. Here we go. The prompt, a quartic polynomial. Quartic means my degree will be what? 4. So we're looking for a quartic polynomial that has rational coefficients. So if radical 2 and 1 plus I are roots of the polynomial, what are the other 2 roots? So going back to what we just said, they have to come in pairs. So they've given me my right shoe here, and they've also given me a different pair of shoes, but they've also given me my right shoe. We need to find the left shoe for both, because as quartic tells us, we need 4 roots, and we only have 2. So the square root of 2 is one of them, and this is positive, so we just need the negative. We've found one more shoe. Now we have this other pair, purple shoes. 1 plus I. So remember, we want them to stay purple, but we need the left shoe, which would be negative. So we'll have 1 minus I. That's it. Yeah, it was that easy. So, how many roots do we now have? 4. 1, 2, 3, 4. 4. Quartic. Quartic means 4. You see how it's all playing together? Like you guys are asking me, like, what is this? Yeah, whatever. Moving on. So I'm realizing how quick this is. And like, instead of me having to explain things 4 times a day, I could just record myself always and just keep playing it. Sounds like a great idea, right? I know. I should have thought about this sooner. All right. Example 4. Using conjugates to construct a polynomial. So now we're basically going to, you know how like they've given us roots and we make an equation with our roots? It's exactly what we're going to do, but now we're just going to do it with conjugate numbers. So multiple choice. What is the 3rd degree polynomial? 3rd degree means we're going to have how many roots? 3. So what is the 3rd degree polynomial function? This is what our function will look like. With rational coefficients, we talked about rational, negative or positive, whole number or fraction. Rational coefficients, so that p of x equals 0 has roots -4 and 2. So they've only given us 2 roots right now, -4 and 2i. Did I say 2? I said something crazy, didn't I? My bad. Y'all can read it. It's -4 and 2i. You'll be fine. So -4 is like us having pants. We only need one. Like it's a whole number. It's not irrational. It's not a complex. It's a whole number. We have a whole pair of pants. Yeah? And then like the 2i, we only got one shoe. It's our right shoe right now. So we got to find our left shoe. Yeah? Well, we know if we have 2i, our left shoe is going to be a -2i. So then we have our 3 roots. Yes? Okay. So now we're going to put these into binomials. And all you have to do is, let me grab black, un momento, dark color. Here we go. Okay, so for this one, it's just x plus 4. So remember, when we're putting them back into binomials, you have to take the opposite. So this is -4, we need to take the opposite. Because if we set this equal to 0 and solve, we would get -4. So that is why it's flipping. Doing the same thing, this is +2i, so we're going to do x minus 2i. And then this one flips to a +2i. Yep. Momo's nodding. That means I'm explaining this good. Okay. Next pretty color, purple. Now we're going to start the distributing process. I'm going to do these 2 first so that I can get rid of my I. I'm going to do the box. So x minus 2i, x plus 2i. So x times x, x squared, x times 2i, that is 2ix. X times into -2ix. That's really little. Don't worry, I'll take a picture. And then here we go. -2 times 2 is -4. I times I is I squared. I squared, remember? Yep. Somebody said it. I know somebody said it. -1. So -4 times -1 will get us a +4. Okay, so now let's simplify our box. These 2 cancel because -2 plus 2, they cancel. And we're left with x squared plus 4 because our x squared and our 4 can't be combined. So we haven't done anything with this yet, so we need to bring it down. And now we distribute again. But I'm going to just do regular FOIL method. Okay, hold on. Okay, so x times x squared, x cubed, x times 4, 4x, 4 times x squared is 4x squared, 4 times 4, 16. Is this in standard form? You should have definitely said no. Definitely. Hold on, we have this right. And we're back. Okay, so we're going to rewrite these because none of them can be combined because they're all different terms. So we're going to rewrite it in standard form. We have x cubed plus 4x squared plus 4x plus 16. So we've taken our roots and we've made it into a function. And so now we're going to go over and look at our A, B, C, D options to see which one does this match with. X cubed, okay, they all work. 4x, positive 4x squared, A's out, B's out, plus 4x, okay, well, D's out, so process of elimination. C is what matches what we just came up with. And that is how you use conjugates to construct a polynomial equation. Okay, now go practice.